Hey, Transmath class, we're going to take a look at the notes for lesson 12, and this is going to be primarily concerned with angles and finding some measures of interior angles, especially with triangles, and then some quadrilaterals too. So this is some of the terminology: additive, interior angles, regular polygons, and equilateral triangles. We'll kind of work through each of those words as they come up. So this question says, can we partition a straight angle into three smaller angles with equal measures? Partition just means to divide, okay? And so if you remember, a straight line is 180 degrees, so it's 180 degrees. Now if we want to divide that into three smaller angles, so if we were going to divide 180 by 3, 3 goes into 18 6 times, that's 18. If we bring down the 0, we'd put a 0 there, 0 times 3 is 0. Okay, so 60 degrees is what we're looking at. So we would draw three 60-degree angles. This would be 60 right here, this angle would be 60, and this angle would be 60, because 60 plus 60 plus 60 would equal the 180, which is the full straight line. Okay? Okay, so we had one of these on our quiz earlier. It said, what is the measure of angle B? Well, again, so if this is a right angle, so if this whole angle here is 90 degrees, right? You can see that square they put right there. And part of it is 70. Then what's left for this part? Well, what we have to do is we have to take the whole thing, which is 90, and subtract the part that they give you, and then see what's left. So 90 minus 70 is 20. Okay, so this angle here would be 20 degrees. 20 plus 70 would equal this right angle that we have. Okay, so angle B equals 20 degrees. What's the sum of the angle measures inside of an equilateral triangle? Okay, well, what we're going to find is that any triangle, when you add the angles inside, they add up to 180. Okay, now if we have an equilateral triangle where all the sides are the same, then our total of 180 again gets divided equally by 3, and we just did that and saw that it was 60. So we get 60 degrees for each angle inside of an equilateral triangle. Okay. So the power concept is that the angle measures inside a triangle have a sum of 180 degrees. Okay, they always add. Sum means they add up to 180 degrees, okay? So what's the sum of the angle measures in a right triangle? Well, again, it says the total is going to be 180. They tell us that for any triangle. We can check it on this one if we want. We got 45 plus 45 plus 90, which is right there, right? So if I add the 90 onto that, I think we're going to see that we get 180. So 1 plus 4 is 5, plus 4 is 9, plus 9 is 18. 180 degrees. So any triangle, doesn't matter if it's a right triangle, doesn't matter if it's equilateral, any kind of triangle, the sum, when you add all three angles, is always going to be 180. Okay, now what's the sum of the angle measures of a square? Well, in a square where there's 4 sides and 4 angles, that's going to add up to more than 180. Okay, so now in this one we have, in a square we know that all the angles are 90 degrees. Okay, so if there's 4 angles that are each 90 degrees, we could multiply 90 times 4. So that would be 0. 4 times 9 is 36. So that would be our answer, 360 degrees. Okay, and so any 4-sided figure, whether it's a square or a rectangle or just like a trapezoid, they will always, the angles will add or have a sum of 360. When you add all 4 angles, they're going to add up to 360. Okay, even if they're not all equal, they will add up to 360. Okay, in this activity it says find the measure of angle A of each polygon. Tell whether a protractor or reasoning about the angles is needed to find the measure. Now, what we're going to do, since we don't have protractors, I'm just going to, maybe we can give an estimate of what this angle is, but we're not going to use protractors for now, okay? And then, then we'll circle yes or no if we would need a protractor to do it. Now in this one, because they don't tell us any of the other measures, and there's not necessarily right angles here. We would need a protractor. Yes, we would need a protractor. Now this is an acute angle, and if we were going to make an estimate on how many degrees, it's got to be less than 90, right? It looks like it's more than like 45. Like if I were to make just to kind of help me out, if I was going to make like a right angle at this corner, it doesn't split that right angle in half. I'm going to say it's maybe about 60 degrees, just as a guess, okay? Now in this one, we've got a rectangle, right? And so I'm going to say in this one, we don't need a protractor because in a rectangle, all the angles are 90 degrees, the right angles. Okay, so this is going to be right here. That's going to be 90 degrees, just like all of them. Okay, now in these next two, we don't have any right angles. We would need protractors for each of these to get the answer. We can see this is an obtuse angle, so maybe we could make a guess that maybe it's, something bigger than 90, maybe 120 degrees, something like that, right? It's less than 180, it's more than 90. This one's acute, so we could again make a guess on it. Maybe it's about 45 degrees. Okay, just as long as if we're reasonable, if it's an obtuse angle, we should have something more than 90. If it's acute, it should be less than 90. Okay, in number 5, it says what's the measure of angle A? Now in this one, because they tell us 2 of the angles, we shouldn't need a protractor. We should be able to figure it out. So if we have 60 plus 60 for 2 of them, that's 120, right? And they told us that triangles always have to have a sum of 180. So we're going to take that 180 and subtract the other 2 angles, minus the 60 and the 60, or minus 120. That's going to leave us with 60 for this last angle. And so that's an equilateral triangle. They all have angles of, if 2 of them are 60, the third one has to be 60, because that's what would add up to 180 degrees. Okay, so that's going to be 60. And that is it for our notes.